As you can see on the chart up there, the big areas for us are the Rocky Mountains, which is pretty much the Bakken play. I also need to mention in 2005 we made a rather large acquisition of 2 properties. That's the Postal Field in the Panhandle of Oklahoma and the North Ward Estes Field down in the Permian Basin of Texas. Big, old, mature fields. Both of those we're utilizing CO2 for enhanced oil recovery. In the Postal Field up in Oklahoma, we're currently injecting about 150 million cubic feet of CO2 a day. At North Ward Estes down in the Permian Basin, we're currently injecting about 250 million cubic feet of CO2 a day in these enhanced oil projects. To date, all of our CO2 is coming from natural sources or coming from geologic sources. We have just recently signed a contract with a company, Texas Summit Energy, and they have a project called Texas Clean Energy Project, which they're building down near the big city of Penwell, Texas. This is a coal gasification plant, and they're going to use coal that they're going to convert into a syngas. They're also going to make some urea for fertilizer and generate power at this plant. We are going to be taking the CO2 from that plant to inject into North Ward Estes, and that plant is scheduled to be online late 2014, 2015. This is very similar to what's going on in Dakota Gasification at Beulah. That CO2 is currently going up to Weyburn in Canada, where they're utilizing it for CO2 purposes. So I've been talking for several minutes up here and haven't really said the B word yet. The Bakken. That might be a record for any talk that I have given here recently. So how did Whiting get involved in the Bakken? What led us to the Bakken? Through the various acquisitions I mentioned earlier, we picked up a small acreage position over in Richland County, Montana. And we were approached by a company by the name of Headington. They were going to drill a horizontal well in this formation over there in a field called Elm Coulee. They're going to drill into the Bakken. And it sounded pretty interesting, so we figured, what the heck, we'll go ahead, and we joined in with Headington and drilled the well. They drilled the well. It produced about 1,000 barrels a day. We thought, hey, that's pretty cool. And so we ended up drilling 5 wells with these guys, and that was all the acreage we had in the Elm Coulee field. So we were done. For us, the party was over. So we tasked our geologic and geophysical teams and said, where else in the Williston Basin could there be another Elm Coulee field? And our guys looked all over, and they searched, and they came back and said, there's this area over in Montreal County that, based on the data we have, we think could be another Elm Coulee. So we went out there and leased about 90,000 acres, and we drilled our first well just north of the town of Newtown, and it produced about 120 barrels a day, so not what we were really after. We drilled several other wells out there and got, sort of similar results. And we were drilling these odd bird foot looking things. We were, when engineers go unsupervised, sometimes they can do some really unusual things. So you might see on the map there are some of those right in the middle that look like a big bird's foot, We were thinking the key to this Bakken was put as much horizontal wellbore as you could in the formation. That's what we were trying to do. That was our goal. And then we were pumping what we called a Hail Mary frac. You just rigged up the pump truck on this thing. You just fracked the whole works. Wherever it went, and that's what happened. Finally, we landed on another technique. We drilled one well across 2 sections, as Kathy just mentioned, 2 miles long, 2 miles of horizontal wellbore. We ran this newfangled completion technique that Baker Oil Tools had developed. It was some swell packers. We ran 10 swell packers, and we ran this new completion system they had called Frac Point. And so we did this, and basically what it did is it divided your horizontal wellbore up. I'm going to talk a little bit about this later. We fracked this well, 10-stage frac. It produced at 1,600 barrels a day, and all of a sudden we thought we're on to something. What you're seeing right here is just a map of Sanish Field out south of Stanley. That's where we were just at the end of June this year, and we've drilled a number of wells out there. It's working very well for us. As Kathy mentioned, the Bakken exists at a depth of about 10,000 feet. So we're drilling down 10,000 feet, or 2 miles, turning the corner, drilling another 2 miles horizontally. To date, Whiting is running somewhere between 30 and 50 swell packers. And let me jump ahead here. That's just the Bakken we've already talked about. This is just a diagram of what we're doing. We run between 30 and 50 swell packers. The swell packers are the little darker gray items out there. What is a swell packer? A swell packer is just simply a rubber donut. It's made out of a special material that when it's contacted by hydrocarbon, it swells. And it swells up and forms a seal between the pipe that we run out in the horizontal and the rock formation. Then in between each one of those swell packers, we run what's called a sliding sleeve. That just allows us to pump a frac job in between those two swell packers. So if we run between 30 and 40 swell packers in a well, we can perform between 30 and 40 individual frac jobs along the length of that wellbore. And we have found that to be working very well for us. We have wells today that will produce anywhere from 2,000 to 5,000 barrels a day out of this Bakken and Three Forks formation. So it's a technique that we have developed with the help of Baker Oil Tools, and it appears to be working very well. I'm just going to throw out a bunch of facts here. I was trying to figure out how to wind these all into a talk, and I couldn't really figure out how to make it sound good. So I'm just going to throw a bunch of items out here so you get an idea of what whiting is about in western North Dakota. The average whiting Bakken or Three Forks well currently costs about $6 million for each well. That's with all the facilities, pumping unit, and all of the things that go along with that. The average drilling rig employs about 30 people. Currently, Whiting has 17 drilling rigs running in the Williston Basin. We have 9 rigs running in Sanish Field. We have 8 rigs running on our other acreage outside of Sanish. Oops, don't need that one. There we go. We are planning to drill 217 wells in western North Dakota this year. Our current budget for 2011 in North Dakota is $767 million. Each well, the pipe that we are going to use to complete our program this year is just over 7 million feet of pipe. You can think that's a number of rail cars that are going to be hauling pipe into North Dakota. Each frac job we pump out there, we place about 1.8 million pounds of sand. If you look at the total number of frac jobs we're going to pump this year, we're going to utilize just over 200,000 tons of frac sand in western North Dakota. Just the logistics of getting all this stuff to western North Dakota are pretty monumental. I was trying, as I was flying up here yesterday, I was trying to count the number of truck trips to each location that it takes to drill a well, because traffic is a huge issue in western North Dakota. And I was just thinking, moving the rig in, building location, all this sort of stuff, I can easily get to over 500 truck trips to each location by the time we get the rig in and out, the frac tanks in and out, the frac tanks filled with water, the frac tanks emptied of water after we flow them back, get all the frac sand in there, have all the people, equipment, and material that we need to drill the well. So there's easily over 500 truck trips to each location as we drill a well. The other thing Kathy talked about, how amazing the technology that we employ. The thing that has amazed me is to drill the 20,000 feet. Currently, for our 9 rigs that we have running in Sanish Field, our average to drill from spud when we start the well to TD is just under 20 days. Our average is about 19.2. The fastest we have drilled a well to 20,000 feet is 11.2 days. So we're drilling over 1,000 feet per day. Our goal that our